So to continue on with our conversation about equilibrium, the first thing I'm going to talk about is actually going over what we've already talked about with regards to the energy path of a reaction, just for us to make sure we understand the difference between endothermic and exothermic reactions, because we're going to use that in this lesson. Okay, so for an endothermic reaction, what that means is that the reactants are absorbing heat. So the heat of the products is going to be greater than the heat of the reactants. And so here's an energy curve that demonstrates that. Notice your products have higher energy than your reactants do. And for an exothermic reaction, your products would have less energy because energy is being released, which means that it would look like this. So keep in mind, if I were to try and add heat to a reaction I was writing, since endothermic reactions gain heat, then heat would be a reactant for an endothermic reaction, while heat would be a product for an exothermic reaction because it is being released, it is being lost. Okay? All right, so we're going to talk about Le Chatelier's principle. So what happens in Le Chatelier's principle is if we are at equilibrium, what happens if we stress that equilibrium? Meaning, what happens if we add reactant, or we change the pressure, or we change the temperature? We're going to have to reestablish equilibrium, and the question is, how exactly do we do that? Is there going to be a shift to the right to make more products, or is there going to be a shift to the left to form more reactants in order to reestablish equilibrium? So, the first change that we can force is changing the concentration at equilibrium, okay? So, if I give you this reaction here, I could change any of these concentrations. These reactants and products coexist, so you'll have carbonic acid, carbon dioxide, and water coexisting in a solution. So the question is, what happens, for example, if I were to add H2CO3, what would happen if I added CO2, or what would happen if I added H2O? And the answer is, if you think about it, if you suddenly add more reactant, what that means is that the rate of your forward reaction is going to increase, meaning you're going to form more CO2 and more H2O. So you would shift to the right. If I increase my concentration of CO2, however, my reverse reaction would speed up, which means I would form more H2CO3. So wherever you see an increase, okay, it's going to go in the opposite direction of that. While if you have a decrease, like if I have a decrease of H2CO3, that means I would see a shift to the left. If you want to imagine just the everyday example of like a party, for example. So if these are two different parties, right, and people are moving from one party to the other, if I suddenly have a bunch of people on my reactant side at my reactant party, what that means is that there's going to be a shift and a number of people are going to move over to my product party, and then equilibrium will be reestablished. So let's look at these examples. So if I add H2CO3, I'm going to have a shift to the right. If I add CO2, however, I'm going to see a shift to the left. And if I remove H2CO3, I'm going to have a shift to the left. All right, so that's concentration. Well, what happens if I change pressure or volume? Okay, so let's look at this example. Okay. You need to write a note to yourself. If you increase pressure of a system, then you're going to shift towards the side that has fewer moles of gas. Okay, so increase pressure, you're going to shift to the side that has fewer moles of gas in order to reestablish equilibrium. So if you look at this, my reactants, I've got 1 mole of N2 and 3 moles of H2, which means I have 4 moles on my reactant side and only 2 on my product side, which means if I increase pressure, I'm going to see a shift to the right. However, if I decrease pressure, it's the exact opposite. If I decrease pressure, I'm going to shift towards the side that has more moles of gas, so I would shift to the left. Now notice I also included volume. Keep in mind, pressure and volume are inversely related. So if I increase pressure, that means I decrease volume. So if I ask the question, what would happen if I decreased volume? In your head, what you have to do is say, all right, if I decrease volume, that means I increase pressure. And if I increase pressure, I'm going to go towards the side with fewer moles of gas. So I'm going to go towards the right. So you can do it for moles, you can do it for changing volume, or you can do it for changing pressure. Keep in mind that everything involved, whenever you're working with this, you need to be just looking at your gases. So notice I said 4 moles of gas and 2 moles of NH3. If N2 were, for example, a liquid, I would only have 3 moles of H2. I wouldn't have 4. So make sure everything that you're counting for moles of gas are actually a gas. The last thing, effect of changing temperature. So if you look here at my reaction, notice heat is on my product side. which means that this reaction is exothermic. If it were endothermic, then it would be on my reactant side. All right. Now, all you have to do for increasing heat or removing heat, just treat it like you're adding a product or removing that product. So if I were to increase heat, imagine increasing the concentration of a product, you would see a shift to the left. While if you removed heat, right, you're removing a product, then you're going to see a shift to the right. Okay, so what exactly do these shifts mean? If we look back at the effects of pressure, if I'm shifting to the right, what that means is I'm going to increase the amount of NH3 I have, and I'm going to decrease the amount of N2 and H2. However, if you look for SO2 and O2, it's super similar, okay? If you shift to the left, you would increase the amount of SO2 and O2, and you would decrease the amount of SO3. But if you shift to the right, then you would decrease the SO2 and O2 while increasing SO3. So that's Le Chatelier's principle. You are putting a stress on your equilibrium and seeing how your equilibrium will respond in order to reestablish equilibrium.